Properties of logarithms. So with logarithms, we can expand them, we can combine them, condense them. It just depends on if we would rather have one logarithm or multiple. So logarithms have some of the same properties as exponents. So we have the product property, which we can use when the inside of a log is being multiplied together. So the way this works is if you have one single log with two multiplied things inside, you can split it up into two separate logs by addition of one argument and the other one. So here's an example. The log of 2 times 4, I can split up into log of 2 plus log of 4. This also works the other way. So if I start on this side where I have two logs added, I can multiply their arguments inside one single log. That's what equals means. It either goes from left to right or it works from right to left. Then we have the quotient property. So if I have one log with a division inside, that means I can subtract two logs, one with the numerator and then minus the denominator. In this case, the order does matter. It needs to be the numerator first, then minus the denominator. So here's an example. Log of 4 over 7. I can split that into 2 by doing log of 4 minus log of 7. 4 was the numerator, 7 was the denominator. And then last we have the power property. So this is with exponents. So if I have log of something to the nth power, I can take that exponent and I can drag it down to the front and put the n multiplied in the front. So for example, if I have log of 4 squared, I can take the 2 on the square and I can put it in the front of the logarithm. So it would be 2 times log of 4. Now, so a couple things. I don't actually need the parentheses because whatever's directly after ln or log, we assume is inside the logarithm. It's the argument of the log. Second thing is, these properties are only able to use when you have like bases. So if I have log base 4 and log base 8, I cannot use these logarithms. So let's do an example. So first we're going to expand logarithms. So we're going to take it and instead of writing it in one log, we're going to write it in several. So there is an order we have to do this. It's kind of following the order of operations. So the first thing we want to expand, except you're going to go backwards in the order of operations. So the first thing we're going to expand is any division. So that would mean we're going to use the quotient property first. Then we're going to undo any multiplication, which means we're going to use the product property. And finally, we're going to get rid of any exponents. So that's the order we're going to expand. So division gets expanded first, then multiplication, and then exponents. So let's look at example number 4. So expand the natural log of 5x to the 7th all over y. So we need to expand division. Well, according to our quotient property, when I have division, I'm going to use subtraction. So I'm going to take the natural log of 5x to the 7th, that's the numerator, minus the natural log of y, that's the denominator. So the first thing we used was the quotient property. Now, I want to get a single argument inside each log if possible, so one thing apiece. So natural log of y is done. I can't do anything else with this, so this guy's just going to kind of tag along the entire time. But I have this guy, natural log of 5x to the 7th. Well, 5 and x to the 7th are being multiplied, so I can use my product property. According to the product property, we're going to add whatever's inside together. So it's going to be natural log of 5 plus natural log of x to the 7th. And again, the minus natural log of y is just going to tag along. So this one was created using the product property. Then I see that natural log of 5 is as simplified as it's going to get because 5 is the only thing inside. But this natural log of x to the 7th, I can do something with that exponent. So we can use the exponent property to move that 7. So natural log of 5 is going to stay, but according to the exponent property, this 7 is going to drop in the front. So it's going to be 7 natural log of x. And again, the minus natural log of y will tag along. So this is using the exponent property, or power. And now that we have a single argument inside each natural log, this is expanded as you are going to get. Example 5. Expand log base 6 of 3x to the 4th. So follow the order. First is division, but I don't have any division. So then we're going to move on to multiplication. So the product property says I'm going to add two separate logs together. So log base 6 of 3 plus log base 6 of x to the 4th. Since 3 and x were multiplied, the property says I can add two separate logs together. So this was the product property. Then I see that I have an exponent of x to the 4th, so log base 6 of 3 is not going to change. Then I can use my exponent property to pull the 4 down to the front. 4 log base 6 of x. And that was the exponent property, or power. Now that there's a single argument inside both logs, this is as expanded as it will get. Example 6, expand log 10x. Now remember, if it doesn't have a base, the base is assumed to be a 10. That'll come in handy in a minute. So again, we don't have division, so the next thing we would look at is multiplication. So 10 and x are being multiplied, so that means I can separate it by having log of 10 plus log of x. Okay, now this is not quite finished, and the reason is this. I said earlier that this was log base 10 of 10. Well, when your base and your argument are the exact same number, these are considered inverses. So log base 10 of 10 is actually equal to 1. So I can make this even simpler. Instead of saying log base 10 of 10, I can say 1 plus log of x. So this is actually as simplified as this will get. Log base 10 of 10 is actually a 1. Same base equals a 1. So we can do that for lots of cases. If we have log base 6 of 6, well, that's a 1. If I have log base 2 of 2, that's a 1. Log base 23 of 23, that's going to be equal to 1. And the list goes on and on. Example 7. Expand natural log of e squared over x plus 1. So I do see division this time, so we're going to have to use our division property first. So it's going to be the natural log of e squared, which is the numerator, minus the natural log of x plus 1, which is the denominator. So this was the quotient. Now, first off, let's look at the second log. If we look at our argument on the second log, this x plus 1, there is no property with addition inside the log. The only thing we can work with is exponents, multiplication, or division. So since this x plus 1 does not have a property, we're going to have to leave it the way it is. Now, let's look at the first one. The natural log of e squared. Well, I can use my exponent rule to pull this to the front. So 2 natural log of e minus the natural log of x plus 1. And that was the exponent property. Then, kind of in the other case before, let's look at this natural log of e. Well, the base of a natural log is e. So this is kind of the same thing we had with log base 10 of 10. The base and the argument are the same. So that means the natural log of e is actually just equal to a 1. So what we really have here is 2 times 1, then minus natural log of x plus 1. And well, 2 times 1 is simply 2. So again, same base and argument means it's going to be equal to a 1. So that was expanding logarithms. Let's talk about condensing logarithms. So now we're going the other way. We're going to take multiple logs and write them in a single log. So this time we're going to be following the order of operations the correct direction. So first thing I need to simplify, or the rule I need to use first, is the exponent rule, if I have it. Then the second thing is actually at the same time multiply and divide from left to right. So if you have subtraction first, that means you're going to use the division rule first. If you have a plus first, you're going to use the multiply rule first. It's just whatever comes first, left to right. So let's look at example 6. So condense log of 9 plus 3 log of 2 minus log of 3. So the first thing I'm going to look for is the exponent rule. That means I have numbers in front of my log. They have coefficients. And I see that that happens here. So the first thing I'm going to do is the exponent. So now we're working these rules backwards. Well, the 3 got in the front because it was the exponent on the 2. So we're going to move it back to the exponent. So we have log of 9. I'm going to use parentheses to help. Plus, then we're going to change this guy to log of 2 to the third minus log of 3. So now that the exponents are taken care of, we're going to work multiply and divide left to right. So I'm going to start here and work to the right. Well, I first see a plus sign, so that means I'm going to have to use my multiply property here. That's the product property. So remember, the product property said if I was multiplying two things, I could add them up. So if I go backwards, if I'm adding two things, that means they will be multiplied inside my log. Then I'm going to keep working left to right again. So left to right, I see that I have subtraction. So that means these two are going to be using the quotient property. So the quotient property was if I had division, that means I could change it to subtraction. So going backwards means subtraction I can change to division. So the first one was the numerator, and the second one was the denominator. Now, because these are all numbers, I can actually simplify this a little bit further. If these were all variables, this would be as far as you could go. But they're numbers, so I'm going to keep going. So I see that I have 2 to the third. Well, 2 to the third is 8 over 3. Then I have 9 times 8, which is 72. And 72 over 3 makes 24. So my final answer, this would be log of 24. Okay, condense natural log of 4 plus 3 natural log 3 minus log of 4. So start with your exponent. So see if you have any coefficients in the front, which in this case I do here in the middle. So this 3 in the front is actually the exponent on this guy. So we're going to have natural log of 4 plus natural log of 3 to the third minus log of 4. Now, instead of waiting to simplify at the end, you can simplify now. So 3 to the third power is actually 27. So instead of waiting till the end, you can kind of simplify as you go if possible. So now we're going to read left to right and work on what operation we come to first. So I see a plus. That means these two logs were actually multiplied together. So natural log of 4 plus natural log of 27 can be changed into natural log of 4 times 27 minus log of 4. So again, simplify as we go here. 4 times 27 makes 108 minus log of 4. Now, this is actually as simplified as we can get. Yes, there is a minus here in the middle, but if you look, this is a natural log which has a base of e, and this is a log with no base. That means it has a base of 10. These bases are not the same. These properties only work when you have like bases. So I can't actually combine this into a single log because their bases are different. So this is as condensed as this expression will be. Number 9, condense log base 2x minus log base 2y plus 3 log base 2 of 4. So look for your exponents first, and I see that there's a coefficient on this final log, which means that coefficient was actually an exponent first. So we have parenthesis log base 2 of x minus log base 2 of y plus, so this 3 is really that 4's exponent. So we're going to have log base 2 of 4 to the third. Okay, now we're going to simplify a little bit. So I'm going to keep all the stuff in the front the same. Now 4 to the third is actually 64. So this is log base 2 of 64. Now, depending on where you have this, we do have parentheses. So we actually have to do whatever's inside the parentheses, even if they fall at the end, no matter what. So because this minus is in the parentheses, this stuff has to go first, even if this parenthesis was over here at the end of my expression. Parentheses must come first. So I really have a subtraction, which means that this was the quotient rule. And that means I can combine these using division. So I'm going to have log base 2 of, the first one's my numerator, the second one is my denominator. Then plus log base 2 of 64. Now that the parentheses are taken care of, I can work left to right. And I see that I end up with a plus. So that means this first log and the second log are going to be using the product rule. So I'm going to be multiplying the insides together. So I have log base 2 of x over y times 64. Now that looks kind of messy, so let's go ahead and multiply these fractions together. So x times 64 makes 64x, and y times 1 makes y. And there's my condensed logarithm. Okay, log of x minus 1 minus 1/3 log x. So again, start with your exponents. I see that I have a coefficient on this last log, so that means that 1/3 is actually this exponent. So we're going to have log of x minus 1 minus log of x to the 1/3. Now, we don't really like fractional exponents, so let's recall that a 1/3 power is actually a cube root. Just like a 1/2 is actually a square root, a 1/4 is actually a fourth root, and the list could go on. If you did x to the 1/6, you would have a sixth root, and so on. So let's go ahead and change that second log into its radical form. There. So now let's continue. Read left to right, and I see that I have a minus, so that means I'm going to use my quotient rule on these two. So quotient rule means I'm going to divide their insides. So I'm going to have log of x minus 1 over the cube root of x. Now that it's condensed into a single log, this is finished.